Hi all of you, once again welcome back to our channel. Now today going to discuss about the elongation of the wire due to its own weight and analogy of rod as a spring and thermal stress and thermal force. First of all, we will discuss about the first of all elongation of the wire due to its own wire అంటే తన యొక్క ఓన్ వెయిట్ వల్ల ఆ తీగలో వచ్చేటువంటి సాగుదలకు సంబంధించినటువంటి ఫార్ములా డిస్కస్ చేస్తాం ఇప్పుడు. నౌ ఫస్ట్ ఆఫ్ ఆల్ డిస్కస్ అబౌట్ ద elongation of wire due to its own wire due to its own wire. First of all, here listen. Simply, this is a wire, this one here, first of all, okay, rigid support, RSA here, rigid support, here, this one rod, this is a rod or just for string or wire, okay, this is a string, this wire suspended from or hanging from rigid support, okay. The length of this rod here L, the length of the rod here L, okay, length of the rod here L. Area of the cross section of this wire A, area of the cross section of this wire here A, okay. Now the density of this wire D, the density of the given this wire D, density of this wire here D, the volume of this wire volume here V, mass of this wire here M, mass of the wire here M. Now the weight of the wire W, initially the weight of the wire here W, okay. First of all, we were discussing about the elongation due to its own weight. ఇక్కడ మనం ఏం చేస్తున్నామంటే ఈ తీగని ఒక దృఢాధారం నుంచి బ్రేలాడదీసి ఆ తీగ యొక్క అడ్డుకోత వైశాల్యం ఏ, దాని యొక్క పొడవు ఎల్, సాంద్రత డి, వాల్యూమ్ వి, మాస్ ఇయర్ ఎం అండ్ వెయిట్ ఎన్ వి డబ్ల్యూ. ఫస్ట్ ఆఫ్ ఆల్ లెట్ us consider the wire of length L, wire of length here L, area of the cross section A. If the density of the wire D, density of the wire here D, then the weight of that wire here, weight of the wire, given wire, the W is equal to here mg, W is equal to here mg. Here m means mass of the given wire. Now according to here density is equal to mass by volume, density is equal to mass by volume. So the mass per unit volume is called as here density, okay. Mass is equal to, simplifies here, mass is equal to dV is equal to m, dV is equal to m. So this is a substituting here weight of the, initially the weight of the wire W is equal to A D V and G initially, but here V is equal to volume of the wire. Volume means length of the wire here L, area of the cross section A. So volume is equal to AL initially starting at the volume AL. This value is here substituting AL. Now initial the weight of that wire here W is equal to AL dV. This is the weight of the wire initially. Now stress is equal to force by area. Here force by area, okay, force by area. That means here stress is equal to force, this is a weight is nothing but here force by area, this one here W by A. So stress is equal to W by A, that is equal to LDG. LDG. So the stress is equal to here LDG. This is a stress. This stress formula. This one here stress formula. The stress of that wire. The weight of the initially W is equal to ALDG. ALDG. Now we were discussed about the elongation due to its own wire. దాని యొక్క సొంత weight వల్ల ఆ తీగలో సాగుదలని మనం ఇప్పుడు కనుక్కోవాలి. అది ఎలా ఫైండ్ హౌ టు ఫైండ్ అవుట్ దిస్ టైప్ ఆఫ్ numerical equation. Now this is the initially. Now after the small element of thickness dx on the at any point, for example here this is the initially. Now small element of thickness here dx, for example this is this one here dx element in the wire. Dx element is a small element thickness of this wire. Okay, this weight, this wire and this dx element distance from free end of the wire is x. Free end of the wire is here x. Free end of the wire is here x. అంటే x నుండి ఎంత దూరంలో ఉంది dx అనేది ఎలిమెంట్, x దూరంలో dx అనే ఎలిమెంట్ x దూరంలో ఉంది. ఎక్కడ నుండి? ఫ్రీ ఎండ్ నుండి. Now the weight of this portion, this portion w prime, for example weight of this portion here w prime. Okay, this weight suspended from this element dx element. The elongation in the dx element here de. The elongation dx in a dx element here de due to the weight of this portion, అంటే ఈ weight వల్ల ఈ dx లో కలిగే సాగుదల de. Now the weight of this portion is equal to here, for example ax, sorry here m means this portion m prime. Okay, the length x, g weight. Now here m means mass of this portion, so mass is equal to density into volume into g. Okay, here v prime means the volume of this portion, this portion. V prime means here volume of the small portion here, this one. So the volume of this portion is equal to v prime is equal to a into the length here x. So the weight of this portion, small portion, is equal to here w prime is equal to d. v prime means ax into g. This is the weight of the wire, this portion wire. Okay, so the elongation in the wire due to this weight, elongation d due to this weight. Now the Young's modulus of this wire here y, Young's modulus of that wire here y. Now the elongation here, the elongation element of small thickness d. Okay, here the elongation of the elongation element of small thickness d in thickness, sorry ఇక్కడ d రాసుకొని సరిపోద్ది, de due to weight here, portion, this portion. Okay, weight here w prime. Now according to Young's modulus, y is equal to force by initial length by here area of the cross section into elongation in the string. Here elongation here de, dA elongation in portion dx portion. Now F means here weight of this portion W, that is equal to here y is equal to W prime, here L means here x, L means here L means this dx portion, L means here length of this wire element portion. So here L is equal to dx by A into here DE. This is a Young's modulus of this portion. Here dx small thickness of the wire, D elongation in the wire dx portion due to the weight here W prime. Now Young's modulus y is equal to W prime dx by A dE. ఇక్కడ మనం చూసినట్టయితే we want only for elongation. DE is equal to here W prime dx by here YA, y into A. This is a small elongation in a dx element. Now this equation W prime values here substituting. This is a W prime values here substituting. Now elongation in the wire element here dx element, DE is equal to W prime is equal to here dA x and G. This is a W prime, okay, into dx, into here dx by YA, by here YA. Here in this equation AA get cancelled, AA here get cancelled, so AA get cancelled. So simplies DE is equal to here remaining terms dGx dx by y. So D is density of the wire, G acceleration due to gravity, and y Young's modulus of the given wire. These are constants. These are here constants. So DE is equal to dG by y into remaining x into dx, x into here dx, x into dx. This is a small elongation in the thickness of dx element. So elongation is equal to dg by y into x dx. Now the total elongation in the wire due to total weight. Now this equation integrating on both sides, 0 to E and 0 to total length L. సో ఈ సమీకరణం మనము 0 నుండి టోటల్ ఎలాంగేషన్ని మనం 0 నుండి టోటల్ లెంత్ తీసుకున్నట్టయితే ఇంటిగ్రేషన్ చేసినట్టయితే we will get total elongation in the wire. Note this one here. Now this equation here, total elongation in the wire, Now here total elongation of wire its own weight, its own weight. Okay, its own weight. So this equation integrating on both sides 0 to E, 0 to L. So here E is equal to integration 0 to E, DE is equal to here DG is constant, DG is here constant by Y, integrating 0 to here total length to L. So remaining X here dx, x here dx. We are integrating 0 to L, 0 to x, for example 0 to n, x power n dx, formula ఇది ఇంటిగ్రేషన్ ఫార్ములా, x into n plus 1 by here n plus 1, అప్పర్ లిమిట్ here l, లోయర్ లిమిట్ 0. ఈ ఫార్ములా మనం సబ్స్టిట్యూట్ చేసుకుంటున్నాం ఇక్కడ, that equation here substituting. So your upper limit L, lower limit 0. Now simplies total elongation in the wire is equal to dg by l y into x square by l x square by 2 your upper limit l lower limit 0 simplies finally is equal to total elongation in the wire due to its own weight is equal to dg by y into here l square by 2 here l square by 2 minus 0 upper limit minus lower limit. Now finally the total elongation in the wire its own weight is equal to l square here l square dg by 2y. This is a total elongation in the wire due to its own weight. ఇది మనకు ఆ తీగ యొక్క సొంత weight వల్ల ఆ తీగలో కలిగే సాగుదల E is equal to L square dg by 2y. This is the equation for the elongation of the wire due to its own weight. For example, దీన్ని ఇంకో రకంగా కూడా చెప్పచ్చు. Consider the weight at center of mass. The weight at here note రాసుకోండి. Note this one. Okay. Next, ఈ ఫార్ములా ఎలా పొందొచ్చో మనం చూద్దాం ఒకసారి. In terms of weight. In terms of here weight E is equal to here E is equal to weight is equal to ఏమొచ్చింది మనకి ALDG. So W by A is equal to here LDG. Okay, in terms of weight this equation write the in terms of weight. Now simplies E is equal to here L into LDG by 2y, but LDG is equal to L length to density acceleration due to gravity is equal to W by A. So that is equal to here E is equal to L into W by A by 2y. So simplies elongation in the wire due to its own weight in terms of weight is equal to here WL by 2AY. This is in terms of weight of the wire. Now here note this one. Note, for example, the total weight. Consider the weight at the center of the mass. And effective length is L by 2. Effective length here L by 2. ఇక్కడ ఏంటంటే మనకి ఇది weight. Okay, the total weight concentrated at center midpoint of the this wire. This is a cm. This one here weight. This is a weight. Okay, this is a weight. The total weight concentrated to midpoint of this wire at the center of the mass. The effective length of this wire here L by 2. The Young's modulus of this wire here by area of the cross section A and this one. So elongation in this total wire here due to its own weight E. According to Young's modulus, y is equal to force into initial length by area of the cross section into elongation. So F means weight, mg. It means mg. Now this here elongation is equal to F L by YA. But here L is equal to effective length. This is a effective length. This one here effective length. So effective length is equal to total length by 2. Half of the length of the wire. That means here elongation is equal to F means mg. It means here mg. Okay. Now here L means L by 2. L means here L by 2 by A. That is equal to here simplies here MGL by 2AY. This is the elongation due to its own weight, or mg is equal to weight total weight. mg is equal to total, that is r here, r. E is equal to WL by 2ay. This is another form of the equation. అంటే ఇంకో రకంగా ఎట్లా పొందవచ్చు దాన్ని, the total weight concentrated at it a weight at center of mass, effective length L by 2, Young's modulus y is equal to FL by AE, E is equal to FL by ఇక్కడ YA. సబ్స్టిట్యూటింగ్ చేస్తే మనకి ఏమొచ్చిందమ్మా, మనకి E is equal to here WL by 2ay, WL by 2ay. Now one case, for example, some weight or some force applied onto end of this wire, okay. Now note this one, here the force applied end of the free end of the wire, for example, this is a force, this one here force applied to the end of the wire. Now total elongation in the wire, this is only this one elongation due to its own wire, E values here, and the applied force this wire F, the total elongation is equal to the addition of elongation of the wire due to this force, some here this one Young's modulus here y, area of the cross section A, and elongation for example E prime here y is equal to FL by E1, okay. First total length, so here elongation of E prime is equal to FL by YA, so this is the additional elongation, that wire. So total elongation. Now case 2, here the force applied to the end of the wire, the total elongation, the total elongation addition to initial elongation, so E is equal to total effective is equal to here E plus E prime. E means this one, E prime means here this one. So these two equations here, so right here simplifies. E is equal to L square G d by 2ay plus E prime is equal to that one here FL by YE. This is a total elongation, okay, total elongation. This one here total elongation. Note this one. Next to thermal stress. Next one here continuation to thermal stress. What is the thermal stress? Okay, note this one. Now thermal stress. Here this one, okay, rod, this is a rod, thermal stress, okay, thermal stress or thermal force, thermal strain. First of all, a rod, area of the cross section A, the length of the rod L. This rod, when placed in between two rigid walls, then as a rise in temperature, of the rod, then this rod tries to expand and exerts force on the ends of the walls. This force is called here thermal force. And the thermal strain, according to the amount of heat energy or heat supplied or temperature increased. This rod increased the change in temperature or increased the temperature. Now this ends of the rods exerts expansion or construction. Expansion or expands or constructive. And both expand కావచ్చు అనేది లేదా కన్స్ట్రక్షన్ కావచ్చు. For example, this rod expansion. So this end of the rod exerts force on the wall. This walls. Two ends. Okay. Force on this ends. According to thermal linear expansion. Initial length, for example, here initial length N. Okay. Exerts force here F. This is a thermal force. This is called here thermal force. ఇక్కడ మనం ఏం చేస్తున్నాం అంటే దేనికి హీట్ను అప్లై చేసినట్టయితే టెంపరేచర్ ఇంక్రీజ్ చేస్తే అదేమి ఎక్స్పాండ్ అవుతుంది. ఫర్ ఎగ్జాంపుల్ ఎక్స్పెన్షన్. ఈ ఎక్స్పాండ్ కావడం వల్ల ఈ రాడ్ యొక్క చివరలో ఈ వాల్ పైన ఫోర్స్ అప్లై చేస్తుంది. సో ది ఫోర్స్ అప్లై టు ది ఏరియా ఆఫ్ దిస్ వాల్. Now at the same time the elongation is increased, and the strain is developed in the rod. This rod. So the thermal expansion. Now here thermal force. First of all, thermal force statement. Thermal force. Okay. Statement రాసుకోండి. First thermal force. When the rod placed in between two walls. Okay, in between two walls. When రాసుకోండి. When the rod placed in between two walls, as a rise in temperature, and the rod tries to expand. Okay, expands and exerts force on the walls, on the end of the walls or on the walls. This force is called here. This force is called thermal force. Here thermal force. This force here thermal force. Now thermal strain. ఇక్కడ ఏమవుతుందంటే ఇనిషియల్ లెంత్ L. The elongation or the expansion of in the rod here, for example, delta L. This delta L means expansion in the rod. L means initial length of the rod. Now thermal expansion of the wire. Now here thermal expansion of the rod is equal to alpha is equal to change in length by original length into delta theta. Here tilde means change in temperature. Tilde means here change in temperature. Delta means change in length. Here L means initial length of the rod. Here alpha means linear quotient of the expansion. Linear quotient of the expansion. Now here delta L by L is equal to, implies here delta L by L is equal to remaining alpha delta theta. Alpha delta theta. Alpha delta theta. Alpha means quotient of linear expansion. Delta means change in temperature of the rod. Here L means initial length of the rod, and delta L means here in the change in length of the rod. This is called here thermal strain. This is a delta L by L means here thermal strain. So thermal strain is equal to here thermal strain. Thermal strain is equal to here delta L by change in length by original, that is equal to here alpha delta theta. Thermal strain is equal to here thermal strain is equal to delta L by L is equal to alpha delta theta. Alpha delta theta. Now thermal force means F. According to Young's modulus, here Young's modulus Y is equal to force into thermal force into elongation original length by here area of the cross section, here area of the cross section A, area of the cross section here A into here in this change in length here elongation due to temperature, rise in temperature here delta L. Now this is the F means here thermal force. F means here thermal force. So thermal force is equal to thermal force is F is equal to thermal force F is equal to cross multiplication, just cross multiplication here Y A delta L by L, delta L by L. This is a thermal force. This one here thermal force. But here delta L by A thermal strain, delta L by A thermal strain. So simplies here thermal force F is equal to thermal force T means thermal force F is equal to delta L by A, nothing but alpha delta theta. So the thermal force is equal to Y A into delta L is equal to alpha delta theta. So here alpha delta theta. This is a thermal force. This one here thermal force formula Y A alpha delta theta. Here Y means Young's modulus, A means area of the cross section, and alpha quotient of the linear expansion of the rod, and here delta theta means here change in temperature of the rod. Now this is a thermal force. Here point note one point. The thermal force independent of the length of the rod, అంటే ఇక్కడ ఏంటంటే థర్మల్ ఫోర్స్ అనేది తీసుకున్నట్టయితే ఆ కడ్డీ యొక్క పొడవు పైన ఆధారపడదు. ఎందుకు ఈ ఈక్వేషన్లో ఎల్ అనేది లేదు, కాబట్టి ద థర్మల్ ఫోర్స్ ఇండిపెండెంట్ ఆఫ్ ద లెంత్ ఆఫ్ ద రాడ్. ఓకే, నెక్స్ట్ continuation. Now thermal stress. Next one here thermal stress. Note this one. This is a important formulas for using NEET and JEE mains. Okay. Thermal force here. Thermal stress is equal to the thermal force per unit area. This is a thermal force formula. Thermal force. Okay. Here thermal stress is equal to here thermal force by area. Thermal force statement here defined as the thermal stress is defined as thermal force for unit area of the rod. It is called as here thermal stress. So thermal stress is equal to thermal force by area. Here thermal force nothing but here YA alpha delta T. So stress is equal to here thermal stress is equal to thermal force here, this is equal to area by okay thermal force by okay y a alpha delta theta by here a. So a get cancelled, a get cancelled, area of the cross section here, so removing from the this equation simplifies here thermal stress is equal to here y alpha delta theta. This is a thermal stress, this one here thermal stress, this is a thermal. So in this case, in this equation there is no length of the area and there is no area of the cross section. సో ఈ ఈక్వేషన్ తీసుకున్నట్టయితే మనకి అందులో లెంత్ కానీ ఏరియా ఆఫ్ ద క్రాస్ సెక్షన్ కానీ లేదు కాబట్టి సో ద థర్మల్ స్ట్రెస్ ఈజ్ ఇండిపెండెంట్ ఆఫ్ length and area of the rod, length and area of the rod. It is the thermal stress independent of length of the rod and area of the cross section of the rod. అంటే థర్మల్ స్ట్రెస్ అనేది మనకి ఆ లెంత్ పైన కానీ దాని యొక్క అడ్డుకోత వైశాల్యం పైన కానీ ఆధారపడదు. సో థర్మల్ స్ట్రెస్ ఓన్లీ డిపెండ్ ఆన్ ఏరియా ఆఫ్ ద యంగ్ స్మాలెస్ ఆఫ్ ద మెటీరియల్ ఆర్ geometry and change in temperature. Okay, this is a thermal stress. This is a equation very important. Okay, next analogy of rod as a string, note this one. Next one, analogy of rod as a string or string, both are different. String ante endi string, both are different. String means wire, spring means మనకి ఇలా వస్తుంది. ఎగ్జాంపుల్ దిస్ వన్ ఇయర్ స్ట్రింగ్, దిస్ ఈజ్ అ స్ప్రింగ్, దిస్ వన్ ఇయర్ స్ట్రింగ్, దిస్ వన్ ఇయర్ స్ప్రింగ్, రెండు వేరే అమ్మండి. ఓకేనా, స్ప్రింగ్ అంటే థ్రెడ్ ఆర్ వైర్, స్ప్రింగ్ అంటే మనము ఇలా తీస్తే సాగేది. దిస్ ఇస్ అ స్ట్రింగ్ ఆర్ thread, this one here spring. Now analogy of rod as a spring, అంటే ఇక్కడ రాడు అనేది ఎలా ప్రవర్తిస్తుంది, స్ప్రింగ్ లా ప్రవర్తిస్తుంది. Now this one rigid support, this one here rigid support, this is a wire or rod, this is a rod. The area of the cross section rod here A, length of this rod here L. Okay, Young's modulus of this rod here Y, Young's modulus of this wire here Y. Now this is a elongation in this wire here, for example E, elongation in the, for example the applied force this rod, for example applied force means okay due to own weight అనుకుందాం. ఇది తీసినట్టు టర్మ్స్ ఏం here area of the cross section of the rod, length of the rod and Young's modulus of the rod here. E means here elongation of the rod. Now according to Young's modulus formula, now here we know here Young's modulus here Y is equal to this one here force into here force is here F. Okay, applied force end of this rod, force into original length by area of the cross section into elongation. This is that means here stress by strain. Young's modulus formula here, stress by strain, the ratio between stress to strain, that is equal to here Young's modulus Y is equal to FL by AA. This is a here as a spring. Now దీన్ని ఎలా కన్సిడర్ చేస్తున్నాం ఇక్కడ యాజ్ ఏ స్ప్రింగ్ లా కన్సిడర్ చేస్తున్నాం. దిస్ ఇస్ అ స్ప్రింగ్, దిస్ ఇస్ అ ఫోర్స్, అప్లైడ్ ఫోర్స్. హియర్ అప్లైడ్ ఫోర్స్. The elongation in the wire here E. So same elongation in the wire here E. Elongation in the wire E. Here K is force constant. Here K is here force constant or spring constant of the spring. Here K అనేది మనకి spring constant or force constant. E elongation in the wire due to this force. Now this rod ఎలా ప్రవర్తిస్తుంది behaves as a spring. So according to spring formula, force is equal to here K into X. Here X is equal to elongation in the wire. X is equal to elongation in the wire. So here F is equal to KE. F is equal to here KE. This is the equation, for example 2. This equation here 1. Equation 1 nothing but here force is equal to F is equal to YAE by L. This is the equation 1. This is the equation 1. This one here equation 2. To compare to the equation 192. Equations 192. ఈక్వేషన్ 1ని 2ని కంపేర్ చేయండి. అంటే 2ను 1తో కంపేర్ చేసినట్టయితే ఇక్కడ మనకి ఏమొస్తుంది? ఈక్వేషన్ 1 is equal to equation here 1 is equal to equation 2. Equation 1 means YAE by L is equal to equation 2 KX. Here K into E. Here E get cancelled. Here E get cancelled. So here force constant K is equal to YA by L. This is a force constant or this is a constant. K is a constant. Force constant or spring constant. So spring constant K is equal to YA by L. So in this rod A is constant, area of the cross section is constant, length of the rod is constant, and Young's modulus of the rod is constant. So here K is equal to YAL. This is the analogy of rod as a spring. Note this one. This is important. Okay. Now for example one problem here, based on rod. For example here, if a mass of rod M, the mass of rod M with attached to the end of the rod, and this mass is stretched and slightly stretched and release it. Now find the time period of the rod. So here Y is a Young's modulus. Now based on this problem, for example ఒక ప్రాబ్లం చూడండి. ఇక్కడ మనకు చూసినట్టయితే this is a rigid support. Okay, here this one here rod, here force the weight of the mass attached to the end of this rod, small m. Okay, this mass slightly stretched and release, then this mass oscillates vertical from its main position. ఈ మెయిన్ పొజిషన్ పై నుండి పైకి కిందికి ఆసిలేషన్ చేస్తుంది. సో find the time period of this mass. Okay, now the Young's modulus of the wire here, area of the cross section A, and weight here, weight is equal to ఇక్కడ మనకు mg. here according to formula, here time period formula means here time period is equal to here 2 pi L by G, or according to spring is equal to 2 pi here m by k. This is a time period. this one taken in string pendulum, this one taken in spring, this one is taken here spring. But here in this case k is equal to, here k is equal to now ya by l, okay, ya by l. So the time period t is equal to, here time period t is equal to 25 m by k. This value is here substituting, so time period of the that mass or string is equal to 25 under root of here m upon ya by l, So finally the time period of the this one t is equal to 25. This is a ml under root of ml by y. This is a time period of the this example problems. Okay, example problems based on the this rod, So the time period of the this is equal to y is equal to 5 under root of ml by y. Here m means mass attached to the this block, this rod, and here y is Young's modulus of the rod, a area of the cross section of the this rod, okay, l length of the rod. For example, the frequency of the this rod, the frequency. So frequency is equal to 1 by t, that is equal to just reverse 1 by 25 under root of here ya by ml. This is a frequency. This one here frequency. Mu is equal to 1 by t, that is equal to 1 by 25 under root of ya by ml. This is our class. Next class continuation చేద్దాం. వాచ్ చేయండి, మన ఛానల్ని షేర్ చేయండి. ఓకే, థ్యాంక్ యూ స్టూడెంట్స్, ఆల్ ది బెస్ట్.